Welcome to the next lecture on the course Introduction to R Software. You may recall that in the last lecture we were discussing some matrix operations, and we started with a discussion on how to do the matrix multiplications in R. We had considered one simple example where we had learned how to multiply a matrix by a constant. Now we are going to explore some more topics on the matrix manipulation, and we will start with the matrix multiplication, particularly when we are trying to multiply two matrices, and then we will try to see some more aspect like as addition, subtraction, and some other details about the matrix operation. Okay, so just for the sake of your understanding, in the last lecture we had created a matrix of order 4 by 2 where the data was arranged in rows and the data was the numbers from 1 to 8. So, the data was arranged in 1, 2, 3, 4, 5, 6, 7 and 8, and this is again the screenshot of that matrix operation. So, and this is the matrix output. So, we are again going to work on this type of matrices. Okay. So, now first we consider how to do the multiplication of two matrices. The first thing what you have to understand, the operator for matrix multiplication is this, which is a percentage sign multiplication and percentage sign. So, the multiplication sign is enclosed inside two percentage signs. This will indicate that this is a matrix multiplication. If you do not use this percentage sign, then it means that this is a simple multiplication, or this is only a multiplication of a scalar with a matrix, right. So, let us try to do some elementary operation and then we try to show that how the things are happening. So, let us try to create two matrices. One matrix I already have, which is here X, and in the earlier lecture we had created another matrix which was the transpose of X. So, these are the two matrices that I already have created, and you can recall that the order of the transpose of X was 2 by 4 and the order of your X matrix is 4 by 2. So, whenever I am trying to multiply them together, then it becomes here 2 by 4 which is of order Tx and say X here 4 by 2. So, these two things are matching. So, my product is well defined, and then ultimately I will get an outcome which is of order 2 by 2 matrix, right. So, as soon as I do so, you can see here. So, when I try to multiply the transpose of X and X, which are two matrices, I try to store their values in this variable name xtx, and this and the outcome of xtx comes out to be like this. So, now let us try to do this thing over the R console and let us try to see how the things happen. Okay. So, now let us come to here R. You may recall that we already had stored this matrix X, and with this we had obtained the transpose of X like this, and so now I am trying to multiply it here transpose of X and multiply it by which is the matrix multiplication. So, say X, and you can see here this comes out to be like this, right. Similarly, if you try to take any two matrices whose orders are well defined for the purpose of matrix multiplication, you can get the same outcome. And we all know that in mathematics this matrix theory helps us a lot, and this matrix manipulations are very important to learn, right, and transpose is one of the basic fundamental operation. And there is another thing which I would try to show you. Suppose you want to find out this multiplication, transpose of X matrix into transpose of X, then we already have shown you how to get it done. Similarly, in case if you have any other two matrices A and B which you want to multiply, suppose and their order condition is satisfied. So, I will try to write down here A percentage star percentage B, there will be no issue. But here I would like to show you that whenever you are trying to find out a particular type of product where you are trying to multiply the transpose of x and x, then there is another built-in command in R which is called as cross prod, which is the cross product of transpose of x and x. So, instead of writing the entire thing, I can simply write here cross prod, and inside the bracket I will try to write down the matrix whose multiplication I want in a way like transpose of its matrix multiplied by the matrix. So, and the advantage of this operation is that this executes the multiplication faster than doing the basic manipulation by transpose of x and multiplication by x matrix. Oh well, here if you try to see, okay, let us try to first see what happens, and then I will try to explain you something more. So, if you try to see here, if I try to write down here cross product of here x, and now you can see here this is the same thing which we have obtained. Now, if I try to say here cross product of x, you can see here that this outcome, earlier outcome, and this outcome is the same, right. Okay. Now, before I go further, I just told you that in case if you try to use the command cross prod, then it is faster and it gives you the faster multiplication, but you have seen that there was no difference in the speed. As soon as you enter, you get the values. But please remember one thing, these are very small number of values. Now, the time has come where we are dealing with high dimensional data, where the order of the matrices may be several thousands even. One thing you have to keep in mind that every software has a limitation for multiplication, finding inverse, and different types of matrix manipulations. And even when you are trying to deal with a matrix of say order 20 by 20 or say 100 by 100, then you will see that what is the difference in the speed of execution of a command in R. In such a 2 by 2 or 4 by 4 matrices, you will not be able to find out the difference in the speed of the operation. And similarly, when I told you about some other basic fundamental like is finding out the dimension of a matrix or number of rows in a matrix or number of columns in a matrix, well, in a matrix of order 2 by 2, 4 by 4 or 5 by 5, we can count by hand. But suppose you are given some matrix of say order say this 200 by 200, it is practically very difficult to find out how to count the number of rows and columns. So, in such situation, these commands like n row or say n col, they help us. Okay. So, okay, now we move ahead and let us try to come on say another aspect that how we can do the addition and subtraction of matrices. So, suppose I have here two matrices A and B. When I am trying to say that I want to add these matrices, we know from the basic fundamental rule that both the matrices should have the same order. So, if this order is P cross Q, there are P number of rows and Q number of columns, then B should also have P number of rows and Q number of columns. So, the order of both the matrices should be same. That you have to keep in mind. Right, this is the basic fundamental. Similarly, when you are trying to subtract two matrices in the same operation, a same fundamental continues that the order of the two matrices A and B, they should be the same. Right. So, and whenever I am trying to do the addition and subtraction, they are operated by simple command like as plus and minus. There is no issue, there is no additional this operator. Right. So, let us try to take some simple example and try to see how we can find out the addition and subtraction. So, I will again continue with our same matrix here X, which was a 4 by 2 matrix and which the data was entered as 1, 2, 3, 4, 5, 6, 7 and 8 row wise. So, I will try to take here the same matrix and I will try to create another matrix and then I will try to show the addition and subtraction. So, I simply try to So, say create another matrix which we had created earlier in the last lecture just by multiplying the matrix X by 4, a scalar, and so we obtain this thing that we had seen in the last lecture. Now, suppose if I want to add these two matrices X and 4 into X, you can see here the command is very simple. You simply have to write down here X plus 4 star X, and you get here the same outcome. Right, and what really happens in this matrix addition? The corresponding elements are added. The element at the address 1 1 is added from say another matrix having the same address 1 1. And when I try to do the subtraction here, the rule is very simple, that I try to, suppose I want to subtract X matrix from 4 star X. So, I simply have to write down here 4 star X minus X, and I get here the same outcome. And the same rule continues for say for example, when we have more than 2 matrices. Suppose we have two matrices A plus B plus C or say and so on, the same rule continues. Even if I have a say combination of addition and subtraction, something like A minus B plus C minus D minus E and so on, the same rule applies over here. Similarly, if I want to hear A plus 2B minus 3C plus 4D and so on, the same rule applies over here. The only thing is this, we have to keep in mind that the orders of the matrix should be the same. So, let us try to do it over R console and try to see how do we obtain it. Okay. So, you have a screen here, this is over here X, and I try to obtain here 4 into X, and now I want to add 4 X and X. So, 4 star X plus here X, you will see here you get here this outcome. And similarly, if you want to subtract it 4 star X minus here X, you get here the same thing. You can see over here. Right. So, you can see here that it is not a very difficult thing. For example, if you want to have it here, suppose we take say another example where I want to have X plus 2 star X minus 3 star X plus 4 star X and so on. You can see here you get the same thing over here. It is not difficult at all. It is just like any other subtraction and multiplication. Right. Okay. So, let us try to continue further, and once again I will request you that you try to do some more examples and try to practice it. Right. Once we have created a matrix, there are situations where I would like to access a particular element of the matrix, a particular row of the matrix, or a particular column of the matrix. So, now I am trying to show you how we can do it. So, I am trying to create now here another matrix, because I am sure that all of you are getting now bored with the same matrix X having the numbers 1 to 8. So, I try to create here, say here another matrix here X, which has 5 number of rows, 3 number of columns, and the data values are the number from 1 to 15, 1, 2, 3, 4 up to 15, and these values are arranged by rows. So, you can see here that now this is going to be here a 5 by 3 matrix whose values are 1 to 15 arranged in rows, something 1, then 2, then 3, and then come here 4, 5, and then here 6, and then come to here 7, 8, and then here 9, and so on. So, once you try to do it over R, you get here this type of screenshot. So, this outcome can be obtained now very easily, and now you can see here that suppose I want to obtain here the suppose third row of this matrix. So, now how to do it here? This I am trying to do it here. I simply have to write down here the name of the matrix and inside the square brackets. Please remember this thing, this is very important. Now, I am going to use the square bracket. Inside the bracket you have to write the third row, and that is all. comma and then blank. Once you try to do so here, you will get the outcome as the third row, you can see here. Similarly, in case if you want to have access to the second column here is the containing the values here 2, 5, 8, 11, 14. Suppose I want to extract only this column from the entire matrix, then I have to give a similar command here, the name of the variable here x, and then I have to write down the square brackets, and then I have to give here blank space, do not write anything, and then comma, and then here 2. So, this will give me an access to the second column, and as soon as you type it, you get this value over here, or this is the screenshot you can see over here. Right. And suppose you want to have a subsection of a matrix. Suppose, just for the sake of understanding, I am trying to take here 4th and 5th rows and second and third column. The symbol, the meaning of this symbol colon is simply from and to. So, this is trying to say here from 4 to 5, and this is trying to say here from 2 to 3. This is about the rows and this is about the columns. So, I am trying to say here that I want to extract here a submatrix which is containing the 4th and 5th rows and second and third columns. So, once you try to do it here, you can see here in this matrix that these are this element 11, 12, 14 and 15, or you can also clearly see over here this is this matrix. So, you can see here that this is governed by this 4 and 5 and this is governed by this 2 and 3. This is how we can obtain a particular element, particular row, particular column, or even a particular submatrix. Let us try to do it over the R console and try to see how it happens. Right. So, first I try to create here this matrix here. Well, I am trying to save my time. Okay. So, if you try to see here, I have this here matrix, the same matrix over here, and now I try to obtain here the same thing, the third row. So, you can see here the third row is containing the values 7, 8 and 9 here, and this is the thing what I have obtained here. Right. Suppose I want to have here information about the second column. So, I have to write down here x, the variable name, matrix name, blank, then comma, and then here 2 and then bracket close. So, I get here the same thing which is here 2, 5, 8, 11, 14, which is here, and then I get it over here. And similarly, if I want to have a particular subsection, so I can write down here like this, and you can see here that 11, 12, 14, 15, this is a subsection of here and say here. Right. Similarly, if you want to have here something here more, for example, if I want to have a 3 to 5 and say here 1 to 3 and so on, this type of submatrix, that can also be obtained over here, and you can see here this is a particular submatrix of the given matrix. Right. Okay. So, once again I would request you that you please try to do some more practice with these things. There is another important aspect in matrix operation to find out the inverse of a matrix. The inverse of a matrix is defined in such a way so that if I have here a matrix here A, and if I try to find out here its inverse A inverse, then their matrix multiplication will give me an identity matrix I. Right. So, how to find out the inverse of a matrix in matrix operation? There is a simple command in R to find out the inverse. Right. This command is here solve, SOLVE, and inside the bracket you have to give the name of the matrix whose inverse you want to find. Why this is actually solved? Those who are familiar with the matrix theory and some linear equation, we always try to find out. We always try to solve the equation something like y ax, and from there, after solving this type of equation, they are trying to obtain the inverse of a matrix, and that is why this is called as solve command in R. Right. So, let us try to take some example and let us try to see here how you can obtain here. So, I have simply taken here a matrix here. For example, here I have created here another matrix. Remember one thing, whenever you are trying to find out the inverse of a matrix, the matrix has to be a square matrix and a positive definite matrix. Right. Earlier I had created a matrix which was of order 4 by 2. I cannot find out the unique inverse of that matrix. Well, there are something like generalized inverse, those things can be found, but here we are not going to that detailed discussion. So, now I try to create here a matrix here, see here y, and you can see here that this is here y here is like this, and so this is essentially a 2 by 2 matrix, and I want to find out its inverse. So, I will say here simply solve y, and this will give us the inverse of this matrix. And if you want to really verify whether this is really an inverse or not, so I will say here, let us try to multiply y and solve y together. So, y, my matrix multiplication, solve, and let us try to see, I get here an identity matrix of order 1 by 1. So, you can be sure that solve is trying to give us the inverse of the matrix. Okay. So, now let us come back to our slides, and the last command which I would like to share with you is another important command in matrix theory to find out the eigenvalues. Right. Here I am not going to discuss how you can find out the eigenvalues in matrix theory, but these are very simple things and they are the part of any elementary course on matrix theory. So, suppose you want to find out the eigenvalues and eigenvectors of a matrix, then the simple command here is eigen, E-I-G-E-N, and inside the bracket you have to write down the name of the matrix of which you want to find out the eigenvalues. Sometimes this eigenvalues and eigenvectors are also called as characteristic roots and characteristic vectors. So, this is the same thing, right. So, here I will try to do the same thing. I try to create here the same matrix which I had used earlier in finding out the inverse of a matrix, and let us try to see it over the R console that how the things happen, right. So, if you see here, we had created this matrix here y, which is here like this one, and so now this is my here 2 by 2 matrix, and yeah, means I have checked it earlier that it is a positive definite matrix, right. So, now if I want to find out its eigenvalue, I simply have to type eigen and inside the bracket say y. So, you can see here that these are the eigenvalues which are obtained, and these are the 2 eigenvectors corresponding to each of the 2 eigenvalues. So, you can see here that these commands are not actually difficult to operate, and you can also see here that I have obtained these things, and then here I am trying to give you these outcomes, and here is the screenshot of finding out the eigenvalues. So, now I would like to stop here, and I will also conclude with the discussion on different types of matrix operation, but definitely I would say that this is not the end, this is only a starting. There are so many matrix operations available, Kronecker product, inner product, Hadamard product, and different types of this inverse like a generalized inverse, Moore-Penrose inverse, right, all those things are there. But again, as I said earlier, my objective is not to teach you here the matrix theory. My objective is simply to help you that how you can do this matrix operations in R which are related to your areas. So, some engineers might have a different type of requirement than those who are dealing with statistics or say mathematics. But these are the basic fundamentals by which you can do your programming, you can write down a function, or even you can do a Monte Carlo simulation. So now I will stop here, but now you have to start and you can go as far as you want depending on your needs and requirement. So he will see you in the next lecture. Till then, goodbye.